This is the first day of solving rational equations. I'm going to work through the odd problems in your notes, and I want you to take the time to complete the even problems on your own. Please come prepared with those before you get to class. You will not receive credit on your notes unless you do have them already completed. So before we get started, I want to look at some steps for solving rational equations. This will help you organize your thoughts as you work through these types of problems. So as always, when dealing with rationals, we are going to factor. Second, you want to state any restrictions. Third, you will find the least common denominator. Our fourth step is to multiply everything by the least common denominator. You will then solve for x, and finally check for extraneous solutions. You saw extraneous solutions with radical equations, and we get them here again. So let's work out number one following these steps. First is to factor. With number one, there is nothing to factor, so we can move to number two. State any restrictions. With a denominator of 3, there's no instance in which the denominators will be 0 here, so there are no restrictions. Third, we're going to find the least common denominator. In this case, the least common denominator is pretty easy. It's just going to be 3. So we'll go ahead and multiply everything by that least common denominator. And we will do that by putting this all in brackets and writing the least common denominator to the side. And then we'll go ahead and distribute that individually to each fraction. So with the first fraction, those 3's divide out and we are left with x plus 1. In the second fraction, the 3's divide out and we are left with x minus 1. And in this third fraction, the 3's divide out and we are just left with 4. So these x's will combine, give us 2x. The 1's will cancel because they are 0, and so that's just equal to 4. Next we'll divide by 2 and end up with x equals 2. So now we've solved for x, we want to check for extraneous solutions. So let's plug this in for x. We end up with 2 plus 1 over 3 plus 2 minus 1 over 3 is equal to 4 over 3. So this is going to be 3 over 3 plus 1 over 3 is equal to 4 over 3. And you can see 3 plus 1 is 4. So we have 4 over 3 equals 4 over 3. So that's good. This is our solution. Next, we are going to look at number 3. So again, we don't have anything that will factor here, but we do have some restrictions. So let's state those restrictions first. X cannot equal 1 or negative 2. Next, we want to find the least common denominator. And I'm going to go ahead and put that outside our brackets so that we can multiply by it. Our least common denominator is going to be 2 times x minus 1 times x plus 2. And now multiplying that through, we see this first fraction, the x minus 1, will divide out, and we are left with 2 times x plus 2. In the second fraction, the x plus 2 divides out, and we have 2 times x minus 1. And in this third fraction, the 2's divide out, so we have x minus 1 times x plus 2. So now distributing everything, 2x plus 4 plus 2x minus 2 equals x squared plus x minus 2. So I'll go ahead and combine like terms and then move everything to the same side so you can see that in 2 steps. 4x minus plus 2 equals x squared plus x minus 2. Now we'll move everything to the right. So subtracting 4x, well, let's put our x squared first. Subtracting 4x, we will have negative 3x, and subtracting 2, we'll have negative 4. Next, we're going to factor x minus 4, x plus 1. So our possible solutions, I'll write them over here. X equals 4 and x equals negative 1. We do need to check these solutions for extraneous solutions. So let's do 4 first. 1 over 4 minus 1 plus 1 over 4 plus 2. And that is equal to 1/2. So 1 over 3 plus 1 over 6 equals 1 over 2. So this is 2 over 6 when we find a common denominator, and 2 plus 1 is going to be 3. So 3 over 6 equals 1 over 2. And that will reduce to 1 over 2. So that works out. The negative 1 over negative 1 minus 1 plus 1 over negative 1 plus 2 equals 1 over 2. So this is going to be negative 1 over 2 plus 1 over 1, which is just 1, equals 1/2. And 1 minus 1/2 is 1/2. So this works out, and our solutions are x equals 4 and x equals negative 1. Number 5. This time we do need to factor in our first step. So this will become x plus 3 and x minus 1. Now our restrictions, x cannot equal negative 3 or 1. We're going to multiply everything by our least common denominator, which is x plus 3 times x minus 1. The first fraction, the x plus 3, divides out, so we have x minus 1. The second fraction, x minus 1, divides out, so we'll have x plus 3. And in this third fraction, both of these will divide out, so we have 4. 2x plus 2 equals 4. So 2x equals 2. Now we can divide by 2 and find that x equals 1. So we only have one possible solution, but if we look back at our restrictions, we see that x cannot equal 1 because that will make our denominator 0. So does this solution work? No. So the answer to this is no solution. Okay, so we had an extraneous solution in this case. You need to be careful of those solutions that don't work. Number 7. Going through the same process here, we'll factor b plus 2, b plus 3. Now we're going to multiply everything by our least common denominator, which is going to be b plus 2 and b plus 3. So this first fraction, everything will divide out, so we're left with the 3. In the next fraction we have b plus 1. Sorry, that's going to be b minus 1 times b plus 3, because the b plus 2 will cancel out. And here we have our b plus 3 dividing out, so we have 7 times b plus 2. Distribute everything, so b squared plus 2b minus 3 equals 7b plus 14. So b squared, our 3's cancel out because 3 minus 3 is 0. So we'll move our 7b over to get minus 5b, and move our 14 over to have minus 14 equals 0. Factor this, b minus 7 times b plus 2. And our possible solutions are b equals 7 and b equals negative 2. The one thing we forgot to do in the process here was state our restrictions. So the restrictions are going to be that b cannot equal negative 2 or negative 3. And we see that one of our solutions is one of the restrictions. So b equals minus 2 is not going to work. Let's go ahead and check 7. So 3 over 7 squared plus 5 times 7 plus 6 plus 7 minus 1 over 7 plus 2 equals 7 over 7 plus 3. So this becomes 3 over 90. I'll let you do the math on your own. This one becomes 6 over 9, and that's equal to 7 over 10. If we multiply this by 10 to get our common denominator, we have 60 over 90, and that will give us 63 over 90 equals 7 over 10. And this can be simplified by dividing by 9. We get 7 over 10. So that checks out. B equals 7. Moving on to the next page. We are going to find out how to solve rational equations using tables and graphs now. So let's look at the table first. I have already filled out my table. All you're going to do is take the left side and plug in values for x to get your function values, and then take the function on the right side and plug in x values to get the values of your function. So here's what I filled in for my table, from -3 to 3 and from -5 to 3. To solve this, note that we are looking for a value of x. Our solution should be stated as a value for x. And what you want to find on the table are any places where the x and y values are the same. So let's look through these. We've got a -3 and a -2. Do we have that over here? Yes, -3, -2. If you look through these, you'll see that none of these exist on the other table until we get to 3 and 1. That occurs over here on the right as well. So I'll go ahead and box the -3 and -2, and the 3 and 1. And as I mentioned before, our solution is going to be a value for x. So we can see from this that x equals -3 and x equals 3. Those are our two solutions. So looking at the graph now, this is a similar process. I've already graphed it, but I just took the points off of this table to get the blue graph. It is a linear function, and I used the points from the right graph, g of x, to get the green equation, or the green graph. So to find our solutions for this equation using a graph, we want to find the points where the two graphs intersect. We can see it happens at these 2 points. Again, we are looking for x values because this equation only has x values, and the solution here is -3 and 3. So no surprise, it came out the same as when we looked at the table. Number 10, I will let you practice by filling out the table and graph yourself. So go ahead and solve that one. To finish off this video, we have one last problem, number 11, and we're going to go ahead and follow the steps that we have been following. Let's factor this to x plus 4 and x minus 1, and state our restrictions. Our restrictions are that x cannot equal -4 or 1. And if you set this one equal to 0 as well, you'll notice that it comes out to 1, so that's already covered. X cannot equal -4 or 1. Before we find our least common denominator, you can state that the least common denominator is x plus 4 times x minus 1 times 1 minus x. However, a simpler way to handle this would be to factor out the negative here, so we have negative x times x minus 1. So negative times x minus 1. And then this negative in front of the fraction and this negative actually change to a plus. So we can scratch out this, change this one to a plus. You can see that this will make solving the equation much easier. Our least common denominator is now x plus 4 times x minus 1. So if we work through this, our first fraction, the x plus 4 divides out, and we're left with x minus 1 equals this second fraction. Both of those terms in the denominator will divide out, so we have 2, plus our x minus 1's will divide out, and we have x plus 4. So here, our x's, if we subtract x on both sides, those go to 0, so we end up with negative 1 equals 6. And we know that negative 1 does not equal 6, so if we have a solution like this that is false, then we have no solution. So no solution is the answer. Go ahead and work out the even problems in your notes, and please be prepared tomorrow to discuss those.